All right, guys, today we're going to be talking about 8.4a, simplifying rational expressions. You may be asking, why in the world did we go from chapter 5 to chapter 8? Well, there's a couple of reasons. One is we're running out of time. Obviously, we're down to about 29, 28 days before we're going to be finished. Also, I want to make sure to get this in before you take off into college algebra, because this is something that they spend a lot of time on. Third reason is because a lot of this kind of work we've already been doing. So it kind of makes sense to go on to chapter 8. But first of all, we were talking about simplifying rational expressions. I want you to notice right here the word rational actually has the word ratio in it. And so when we're talking about rational expressions, I want you to understand that those are going to be stated as ratios. So a lot of what we're going to be dealing with is fractions. Okay, the only difference is now we have exponents in here. And you're going to see as well that we're going to be using some of the stuff that we looked at in chapter 4, which was a huge chapter on quadratics. So there's going to be a little bit of everything that's going to be thrown at you here. But I want to start again. We're just simplifying today, so we're just taking expressions and trying to simplify those things. So, for example, if I had, and this will be a good example to get us started on, if I had 2 divided by 4, right? That fraction can actually be simplified because there is a greatest common factor. And I know we've said that a lot, but it bears repeating again. Greatest common factor. There's a greatest common factor that'll go into both of these. Okay, so the number 2 will go into both of these, which means I could take this 2 divided by 2, which would leave me with 1, and this 4 divided by 2 would leave me with 2. Another way to think about this is, for example, I really got 2 over 2 times 2, okay? So anytime I have the same number over itself, those two are just going to cancel out. And I can only do that with one set of those numbers, okay? So in other words, here I have a 2 on top and I have 1 2 on bottom. I've still got 1 2 left on the bottom. So that's going to mean that this would again equal 1/2. So you kind of get the idea of how that this is going to work. We're basically just simplifying fractions. The only difference is that we also have some exponents in here as well. So I'm going to go ahead and erase this out real quick. Okay, if it's going to, I don't know. There we go. So I'm going to erase that part out, and I'll leave the GCF part because that's going to be a good reminder for us. So here we have 21x to the 4th over 42x to the 3rd. We're working on number 1 right here. And so the first thing I want to do is look for a GCF. Now, if I'm looking for GCF among the coefficients, which are these numbers here, then I want to look actually for the smallest number, okay? So the smallest number here is actually 21. So think about the factors of 21. I have 1 and 21, and I think 3 and 7 are the only factors there. Well, I'm trying to find the biggest factor that'll go into both numbers. Well, I'm obviously going to start with the biggest number I have here, which is 21. And it just so happens that 21 will go into 42, okay? So when I simplify this, I'm going to go ahead and say, well, how many times will 21 go into 21? It goes into it 1 time. And then you notice how many times will 21 go into 42? Well, it goes into that 2 times. So I'm going to go ahead and kind of simplify the coefficients first. Now, I want you to notice here now that I have, and I'm going to put this in a different color, I've got x to the 4th over x to the 3rd. And we could really write that out as x times x times x times x, okay? And the same thing for x to the 3rd, I could write that out as x times x times x, okay? And you don't have to do this every time. I'm just kind of showing you why this works. So remember we said that anytime you have the same thing over itself, those will actually cancel out. So notice what happens here. These will cancel out, these will cancel out, and these will cancel out, which leaves me with 1x, but I want you to notice where that 1x is. The 1x is on the top, not on the bottom, okay? So this helps us to understand a little bit about why we're going to get the answer that we're going to get. And so we're left with 1 over 2 and 1x, okay? And really, I wouldn't really need this 1 right here. And so this is going to equal x over 2. Now, what I do want to talk about is how that this says simplify each and state the excluded values. What does it mean by excluded values? What it means here is there are certain values of x that will make this thing undefined. And so remember we talked about this a little bit before. If I take 0 divided by 6, I'm going to get 0. But if I take 6 divided by 0, that is going to be undefined, okay? So this particular expression is undefined when this x right here equals 0, okay? So what value could I put there that would make that to be true? Well, the value that I could put there that would make this a problem would in fact be 0. If x equals 0 here, x to the third is a 0, and 0 times 42 is 0. So that makes this undefined, okay? So the only other thing we have to do over here with our answer, this is actually our answer, but we also need to put that x cannot equal, okay, cannot equal 0, okay? So this would be the other part of our answer. It's kind of like a two-part answer, okay? So now let's look down. I want to actually go down to number 11, and then I'm going to come back to number 5, okay? So let's go down to number 11. So number 11 here, I'm doing the same exact thing. I'm looking for GCF. I'm going to go ahead and change this to black. I'm looking for GCF. So here are my coefficients, 63, 63, 27, and 36. Again, I'm always looking at the smallest number. Even though it's greatest common factor, I am still looking at the smallest number. So the smallest number happens to be 27. Factors of 27 is 1 and 27, 3 and 9, and I think that's it. So now we're thinking about, okay, does 27 go into these numbers? Well, 27 definitely does not go into 36, so I can stop right there. I don't even need to go any further. Next, we think, okay, well, does 9 go into 27? Well, yes, it does, because it's a factor. What about 36? Yes, 9 will as well, and 9 will also go into 63. So now we have found our greatest common factor. So what I'm going to do is divide all of these terms out by a 9, because I know that I could basically pull a 9 out of every single term. All right, so when I rewrite this, 63 divided by 9 is 7. The k is just going to kind of come along for the ride. Minus 63 again divided by 9 is 7. And then 27 divided by 9 would be 3. That's my other factor right here. 3k plus 36 divided by 9 is going to equal 4. So now I've pretty well factored out. You notice there's no k in every term. In order for these to cancel, I know we might be tempted to cancel those out, but they literally have to be in every term, and you notice they're only in 2 terms here. So I cannot cancel those out. The only other thing I really could do is I could go ahead and pull out a 7 up here at the top, and that would make this k minus 1. Still, that doesn't really help me because that doesn't give me anything to really cancel out. Okay, there's nothing on top and bottom that will both cancel out. So the only thing left to do now is this is actually my answer here. We have to talk about those restrictions, those exclusions. So again, if this equals 0, I'm in trouble. So what I'm going to do, I'm going to go ahead and set this equal to 0. 3k plus 4 equals 0. I need to subtract 4 from both sides in order to solve this. So I end up with 3k equals negative 4 divided by 3. And you notice that k equals negative 4 thirds. Okay, so if k equals negative 4 thirds, I have a problem. It's undefined. So k cannot equal negative 4 thirds. If it does, this is going to be undefined. So this is kind of the other part of my answer. Okay, so two basic answers there that you're going to get for each one of these. What the exclusions are. Some of them may not have any exclusions at all. I think all the ones you're going to be working do. So you need to state those exclusions as well. So last but certainly not least, let's go up to number 5. This is a dandy. Okay, and just by looking at it, you're thinking, oh my goodness, here we go again, chapter 4. What I want you to notice is on the bottom, I don't really have anything I could do right now. It's just kind of 4 minus n. There's no like terms. There's really nothing I can do here, okay? What I do want you to notice is on the top, though, you notice that I have a 1 right here, okay? And we remember from ax squared plus bx plus c, remember our standard form, that as long as a equals 1, then I could look to c and maybe factor this out. Remember, always trying to simplify this. We're always trying to get it down to its simplest form, okay? So I'm going to look at the factors of 16. You will remember. And I'm going to do that over here. Factors of 16 is 1 and 16, 2 and 8, 4 and 4. And I think that's all we have. Notice I have addition here, so that means I need to add 2 of these numbers to make a negative 8. Okay, I need to make a negative 8 somehow, some way. Well, it just so happens that these 2 numbers would add up to 8, but in order to make a negative 8, both of these would have to be negative. Okay, so again, this should bring back some memories, good or bad memories, I'm not sure. I could write this as 2 binomials, and it would be n minus 4 and n minus 4. Now, the way this sits right now, we're thinking, okay, well, that's all fine and good, but I want you to understand that this right here, let me circle this in a different color. This is not the same as this, okay? And I want to prove it to you. Let's go ahead and rewrite this one right here so the n is in the front. Well, notice this negative is with the n. So actually, this is negative n plus 4, which again is not the same as this term up here that I have. So let's just go ahead and rewrite it real quick just so we can see. N minus 4 times n minus 4 over, and I'll go ahead and put it in parentheses, negative n plus 4, just so we can kind of see the differences, okay? Now, what can I do to this bottom term that would make this look like that? Okay, basically, I just have different signs. Notice this is a positive n and this is a negative n. Notice this is a negative 4 and this is a positive 4. So if only I could pull out a negative 1 out to the front and factor that out kind of. Well, if I factored a negative 1 out of here, what would happen to this negative n? Well, that would become a positive n. And if I factored a negative 1 out of a positive 4, that would actually become, excuse me, that would actually become a negative 4. So now look what I have. I actually have one grouping here that are exactly the same. I have n minus 4 and I have n minus 4. Now remember, like the example we did a few minutes ago, you can only get rid of one group at a time unless you actually have 2 groups on the bottom. Well, we only have one group on the bottom, right? So I can only cancel out one of these on the bottom and one of these on the top, which means that I still have left, and I'm going to bring my work down here, I still have n minus 4 on the top divided by a negative 1. Well, anything over 1 is just itself. The only difference is now I have a negative, okay? So what that means is this. Whoa, I did not mean to do that. What that means is really I have negative n minus 4, okay? Now that negative applies to everything here, not just one thing. Okay, so the last step I could do here is I could go ahead and distribute this negative back through negative n plus 4. Okay, so this would be my final answer. The only thing is, again, we have to think about exclusions or restrictions. So let's go back to our original problem, and I want you to just think about something for just a second. What would make this right here, and I'm going to circle it or something here so that you can see it. What color have I not used? I use the pink. What would make this equal 0? Okay. What number could I put right in there for n that would make this equal 0? Well, if that n is 4, then I'm going to have 4 minus 4, which equals 0. Okay. So my only other restriction that I have to put down here is n cannot equal 4. If n equals 4, then I have an issue, okay? And it's going to equal 0. So this would be my 2 answers that I would have for number 5. A little bit of a long problem, but you're going to have one very similar, so I wanted to make sure to go over that. So pretty simple, basically just simplifying fractions. Sometimes you're going to have to factor. Sometimes you're going to have to even factor a quadratic in order to be able to do that. But you can absolutely do this, okay? If you need any help, just make sure to reach out to me or Miss Wheeler, and we'd be glad to get in touch with you.